Hi guys, Dowlath Physics here. So we are going to look today at June 2016, paper 2, number 2. Complete the bubbles below by inserting the SI unit which matches each physical quantity. So when we talk about SI unit, that means that we're talking about a standard international unit that can describe both base as well as derived quantities. So when we talk about force, we could use the Newton. Now, as you guys know from Newton's second law, the force is the mass by the acceleration. The force that we are speaking about is a resultant force that is responsible for changing the velocity of a body. So when we look at that product, we could also engage that the unit of the Newton can alternatively be written as the unit of mass, which is kilograms, as well as acceleration, which is meter per second squared. So alternatively, we can describe the Newton as kilogram meters per second squared. Now, momentum is another example, like force, of a vector quantity. Now, you would recall that vector quantities describe quantities that have both magnitude as well as direction. So if I'm going in one particular direction, my value is positive. If I am changing direction, it is negative. So when we talk about momentum, we describe it as common P, so it is mass by velocity. So it is kilogram and velocity is meter per second. Now, Newton's laws describe how forces are applied to the motion of a body. When we speak about Newton's third law of motion, we are speaking about forces existing in pairs. So as simple as if I had a table and I am resting an object on this table, the weight of the object is going to act down, and because there is contact between the object and the table, there is going to be a reaction force. So when we describe Newton's third law of motion, we are describing what happens when two bodies are resting on each other. So if I have as simple as body A exerting a force on body B, then body B exerts an equivalent opposite force on body A. Alright, so in this part of the question, it's dealing with having an airplane flying horizontally in mid-flight. So when you read the question, you can feel free to pause the video and read the question. You will notice that the airplane is flying horizontally. So there are certain phrases that are very important in guiding us in designing our answer. So when it flies horizontally in mid-flight, that simply means, guys, that you have no vertical motion experienced by this airplane. So whatever forces, let's say I have a lift and I have a weight force, those two will be equal. So what will be happening is that we don't consider them in this motion. Now, horizontally, using Newton's third law, you can consider the rocket as burning fuel. Right? Well, this is not a rocket, sorry, this is an airplane. And it burns fuels. So what happens is that it ejects a certain mass of air, all right, a mass of fuel. And what happens is that that mass is going to act as a second body. And it's going to exert an equal and opposite force back on this rocket. And that, guys, that pair of forces is what tends to propel your rocket forward. In part C, they ask you to define the term linear momentum. So when we define linear momentum, we defined it as the product of mass and velocity. So even though it states linear, that just describes momentum in a straight line in a particular direction. An 8-kilogram ball traveling to the east of 10 meters per second collides with a 2-kilogram ball traveling to the west with a velocity of 5 meters per second. After the collision, they move together. Determine the final velocity of the balls, assuming there are no resistive forces. Okay, so if you're talking about the final velocity, right? You want to describe the motion. So I like to draw a diagram. Now, because these are vector quantities, the fact that one ball goes in an easterly direction and the other goes westerly means you choose which direction is positive. So the other velocity is negative. In this question, I chose to the east as positive. So the ball traveling to the west is also having a negative velocity. Now, because we are using the principle of conservation of momentum, we are simply describing that the balls moving towards each other will do so in opposite directions. That's what we term a head-on collision. Now, the challenge with a head-on collision is that you have to ensure that one of the velocity values are negative. So hence one of the momentums will be negative with respect to the other. So momentums are mass by velocity. So it's 8 by 10, which is eta, plus 2 by negative 5. The reason why I say negative 5 is, again, I chose to the east as positive. So if I was moving to the west, that's negative. So my total momentum before is eta minus 10, which is 70. Now, after the collision, both balls stick together and they move at a certain velocity. So when they do that, it is 8 plus 2, which is 10. And then they move with a certain velocity v. So when they move with a certain velocity v, our total momentum after will just be 10 by v. All right, so 70 is 10v, so we can work out v, which is positive 7. Now, the fact that I have v as positive, it just means that I am moving in the direction I chose as positive, which would be to the east.